Okay, then there is something called Gyromagnetic Ratio. So listen here. Momentum is equal to mass into velocity. More accurately, this is linear momentum. If I want angular momentum, right? Angular momentum. I think some books use L, some books use J, so it doesn't matter. I think your book is using J, so let's go by that. So what is the equivalent of velocity? Linear velocity is V. What is the angular velocity? Omega. Okay, so in place of V, I can put omega. What is the equivalent of mass? Momentum? Inertia. Very good. So that means it is I. I is equal to mr square. Nobody remembers. What is the meaning of that? What do you mean by mass? Amount of matter. Okay, very good. Any other way of understanding mass? Something like, let's say I have this object, right? So it's like if I give a small amount of force, it's moving, right? So this is a table here. I have some objects here, so I'm giving the same force. It's not moving. Why? The mass is more, or in other words, mass is a measure of inertia. Okay, how inert the object is. So bigger the mass it is, more inertia in it. Okay, so when you say angular, right? So this is for linear. Okay, so there is something called angular moment of inertia. Moment of inertia means, so this is for linear, right? So in the case of rotational thing, how much inertia it has got. Okay, so what it means is, again, it's not really required for this topic, but I think you need to have some good understanding. I can show you a small experiment here. So I have some heavy object here, right? So it's almost like maybe like 3 kgs or more than that. So carefully listen to this. So if I want to push this, right, it's a little bit easier. But if I want to push this, it's a little bit harder, right? Because the mass here is higher. But I just want to make it into one mass. And I will keep it somewhere here, right? I'm just going to use my left hand. So observe what I'm trying to do. So I'm trying to turn this. I feel pretty difficult. Okay. So if you want, you can try this later when you're here. And I'm going to do the same thing by keeping it somewhere here. See, I can't even turn. It's pretty hard. Okay. So now I'm going to bring it closer. Okay. Did you see that? So I'm not giving much of effort at all. It's very easy to move. Whereas if I keep it here, you see, it's not the same case. So what do you think makes a difference? I'm not doing any kind of acting or anything, so if you doubt me, you can come and try it yourself. Radius? Radius of gyration. Displacement. Okay. So what it matters is, it's not only the mass, the radius also matters. In the case of rotational movement, right? What determines the inertia is, it doesn't matter how big the mass is. It also matters where it is from the center. Are you following what I'm saying? So that means moment of inertia, for linear inertia it is only mass. For rotational inertia it is mass and radius. So that is what moment of inertia means. So moment of inertia I is given as mr square. Okay. So as the r increases, inertia also That's why I'm finding it very difficult to move it. So this is the meaning of moment of inertia. Okay. In fact, this will find a lot of application in when you, in case if you become an automobile engineer, you will be studying the wheels, right? The way the wheels are designed, right? You have to increase the moment of inertia. So that's why instead of putting the mass everywhere here, right? So they're putting the mass only in the rim. Okay? So when you put all the mass outside, right, and the R is bigger, moment of inertia will be bigger. So look at this. J is equal to I omega. I is mr square. Omega is equal to, what is the relationship between V and omega? V is equal to R omega, right? Omega squared by R. I think R omega, right? So V is equal to R omega. So omega can be written as V by R. So R cancels. So I'll get mr dr mdr. So that is your momentum. Angular momentum is given by this. Okay. So all these things are from your 11th standard basics. Okay. So you don't have to write all these things in your exams. It's only for your understanding. Okay. So however, since we are talking about this one, right? So we want to find the gyromagnetic ratio. So the electron is spinning around like this, the velocity v. Let's say the mass of the electron is me. The reason I'm putting the E is because it's a mass of electron. Okay. The m, since I have another term called magnetic moment, it is a bit confusing. So that's why I'm using me as a mass of electron. So this m is magnetic dipole moment. This m is mass of electron. So that means I can say from this formula I can say m is equal to rev by 2. And from this formula I can say angular momentum. So this is magnetic dipole moment. This is angular momentum. So J is equal to mvr. But what did I say? If you don't put this, you may think that this m and this m are same. Okay, so both are different. So if I did 1 by 2, 1 divided by 2. So m by j is equal to rev by 2 divided by mevr. So what can you say here? R cancels, VV cancels, ME will come here, right? Because it is, when it goes on the top, it will become 1 by ME, so it will be here. So it will be E divided by 2ME. I told you many times this is a subscript, which means you have to write it a little bit smaller. Otherwise, it will look like M into E. Okay. What can you say about E? Is that a constant or a variable? Constant, 1.6 into 10 power minus 19. What can you say about mass of electron? It is also 9.1 into 10 power minus 31, right? So that means this actually turns out to be a constant. Okay, so that's why this constant is called gyromagnetic ratio. This constant is called gyromagnetic ratio. So if you want the answer of this, the value of this would be 1.6 into 10 power minus 19 divided by 2 into 9.1 into 10 power minus 31. So when 10 power minus 31 goes on the top, it will become 10 power plus 31. 31 minus 19 will become 12. So 10 power 12. So 10 power 12. So if I give 1 10 here, so it will be 16 by 2, 8. 8, 10, 10 cancel. So 8 into 10 power 10. I think that's what you will get here. Approximately you will get around 8 into 10 power 10. Because I will get 10 power 12 here. This is 1.6 divided by 2. This is 9.1. Yeah. Yeah, you can calculate that. Basically, it's going to come very close to 8. But I think, as I told you, you should not waste too much time in calculating all this, decimal points. Okay? Nobody cares. As long as you know the concept, you can always use your calculators in your real life. Unfortunately, until you cross your 12th standard, until you enter into college, you will have to do this. Not allowed. Calculators are not allowed. Okay, so this is what is called gyromagnetic ratio. Again, why do we call it as gyromagnetic ratio constant? Because this is a constant, this is a constant. Okay. Usually there will be a negative term here, which I forgot to put. So the negative term represents that. Negative represents M and J are in opposite direction. Okay, I'll try to explain that. So again, let us go back to some 11th standard basics. So tau is equal to R cross F. Okay. So if I take a circular disk, if I take this as R vector, right? This is F vector, right? So if I push the disk this way, which way is it going to rotate? This way or this way? It's going to rotate this way. So it's R cross F. But when you are using this cross product, always remember the tails should be touching each other, right? In this position, if I take R cross F, it will look like R is here, then F is here, so it will go like this. But then actually, when you are applying this, always remember the tails should be touching each other. So F is here, R is here, F is here. So R, F. Why? Because in vectors, right? Important rule in vectors is you can move it wherever you want. So the same vector, I can put it here, I can put it here, I can put it here, I can move wherever I want. Okay, so that's the rule in vectors. As long as I don't change the direction, right? And I don't change the magnitude, I can put it wherever I want, which means I can put it here, which means both the tails will be touching each other. Now you are allowed to do the R cross F. So R cross F. So look at this R cross F. So if I go like this, R is here, R cross F will go like this. So look at my thumb, it's like this. So what it means is the torque direction is taken like this, meaning it's going to rotate like this. So if the rotation direction is like this, the thumb represents the torque direction. Okay. Are you following what I'm saying? because torque is a rotational motion, right? So it doesn't have a direction as such. But what we are saying is if you go by the right hand thumb rule, that is your direction for torque. So if it's going like this, then this is my direction. Again, this is some basics. So similar to this formula, you have a formula for the angular momentum. So it's like J R cross. So remember, in the case of linear world, right, it is force. In the case of rotational world, it is torque, right? So if I multiply by R, it becomes rotational. So similarly, what is that in linear world? It is T. If I take the cross product with R, it will become rotational. So it's another formula you must have studied. But if you are not studying, at least now study this. Okay. In fact, you can see there. What is M into B? What is MB? Momentum. What is R? R. Right? That is magnitude form. This is vector form. Following what I'm saying? So I'm asking you to check this and this. Okay. So this is magnitude. This is vector form. What is the doubt, Ishan? What is the doubt? What is the doubt? I don't understand. Rotational direction. It doesn't matter A into B or B into A, it is same in magnitude. J into J into R is P. Where did we say that? Where did you say J into R is P? You never said that. Okay, so coming back to this, whenever you have cross product, you know how to find the direction, right? So that means, look at this. So if I take the electron spinning around here, right? This is, I said, velocity. This is electron, right? I told you the electron is spinning this way, but the current is this way, right? So the velocity is this way. So mass into velocity is this way. So which way is the momentum? Momentum is this way or opposite? Momentum will also be in the same direction as velocity. So that means mass into velocity will give me momentum in this direction, right? So now look at this. It's very similar to this one. So I have a R here, R vector. So R can be moved over here, right? So R cross P. So again, this is three-dimensional. Imagine it is somewhere here. So R cross P. So in this plane. So look at my thumb. So that gives me my direction of angular momentum. So the angular momentum will go this way. So the direction of angular momentum will be taken this way. In issues here, R cross P. Can use right hand thumb rule. But in the case of Mia, what did we say? I is going like this, so look at my thumb. That is my Mia direction. M-I-A, right? So that means magnetic momentum is this way. So J is equal to R cross P, M is equal to I A. Yeah. So what can you say about the direction? So this is the reason you can say here J and M are in opposite direction. So sometimes, listen here, sometimes they may give you this and they may ask you this. Since this is a constant, you can easily find the other one. Okay. Okay, let us check how much you understood in units. Tell me what will be the unit of this. The ratio means you will not have units. Velocity is equal to distance by time, which means meter per second. Right? Coulomb per, what is mass? Kg. So it will be coulomb per kg. Okay. Ratio means it's not like no units. Okay. If it is same elements meter by meter, then both will cancel. Then you will not have any units. Right? Otherwise, you will have corresponding units. Okay, let's come back here. Mia, what is the unit for magnetic moment? Tesla. Simply go by simple things. Ampere, meter square. Very good. So ampere, meter square. Very simple, right? This is ampere. This is meter square. Ampere, meter square. Okay. Magnetic field is what is Tesla. Okay. So this is magnetic dipole moment. So both are defined differently. What can you say about the unit for angular momentum? Whenever I say unit, go for an easy formula and then look at that. kg meter square by second, right? So it will be kg meter square by second. Okay. If you know the units, you can always arrive at the dimensions, right? Any issues with that? kg will be m. M square will become L square, length square. Yes. S power minus 1 will become T power minus 1, right? So if you know the units, you can always arrive at the dimension. If you know the formula, you can always arrive at the units. Very easy. Okay. So for example, this would be L squared M T power